So hello and welcome back. Today we will continue our discussion of complex number math using your calculator. And recall that whether you have a TI-89, TI-Inspire, or something before a TI-89, it's a different procedure. But let's continue to practice on example 2. So here we have three equations and we want to solve for I1, I2, and IX. So in step 1, we rewrite the equations by grouping like terms. So equation 1 is 13 minus J14 I1 plus negative 12 plus J16 I2 plus 0 IX equals 150. Equation 2 is negative 12 plus J16 I1 plus 13 minus J3 I2 plus 39X equals 0. And equation 3 is I1 minus I2 minus IX equals 0. And then we're going to create a 6 by 8 matrix where the 6 rows represent the 3 equations, 2 rows per equation. And the 8 columns represent each of our variables and the constant on the right side of the equal sign. So our columns represent I1, I2, IX, which equals a constant. So our first column represents the first complex numbers. So it's 13, negative 14, negative 12, 16, and 1, 0. Our second column represents the coefficients on I2. Negative 12, 16 for equation 1, 13, negative 13 for equation 2, negative 1, 0 for equation 3. And our third column would be 0, 0, 39, 0, negative 1, 0. And the fifth column would be 150, 0, 0, 0, 0, 0. Then we go back and we fill in our even columns where we negate only the second number and we swap it with the first number. So we have 14, 13, negative 16, negative 12, 0, 1 for column 2. We have negative 16, negative 12, 13, 13, 0, negative 1 for column 4. And 0, 0, 0, 39, 0, negative 1 for column 6. And column 8 is 0, 150, 0, 0, 0, 0. Remember, we then do reduced row echelon form on this matrix, which yields the answers, which are I1 equals negative 26 minus J52 amps, or 58 with an angle of negative 117 degrees. I2 is negative 24 minus J58 amps, or 63 with an angle of negative 112 degrees. And I6 is negative 2 plus J6, which is 6.32 with an angle of 108 degrees. Example 3, use your calculator to solve the following equation, V1 over 5 plus V1 over negative J 2.22 plus V1 over J5 plus V1 minus 100 with an angle of negative 90 degrees over 20, and that equals 100 with an angle of 0 degrees. So similarly before, even though it's not a system of equations, we still collect like terms. So all of the terms with V1 will be on the left and all of the constants will be on the right. So we'll have V1 times the quantity, 1/5 plus 1 over negative J 2.22 plus 1 over J5 plus 1 over 20. And that equals 100 with an angle of 0 degrees plus 100 with an angle of negative 90 degrees over 20. So we put that in our calculator and we get 0.25 plus J 0.25 V1 equals 100 minus J5. And finally, we divide and we get V1 equals 190 minus J 210 volts, or 283 with an angle of negative 47.8 degrees. Okay, let's try an example that was created from a node voltage method. So once again, we're going to have three equations, 1, 2, and 3, and we're going to collect like terms. So for equation 1 becomes 1 over 10 plus 1 over 1 plus J2 times V1 plus negative 1 over 1 plus J2 times V2, and that equals 10.6. So we can simplify equation 1 and write it as 0.3 minus J 0.4 V1 plus negative 0.2 plus j 0.4 v2 plus 0ix, and that equals 10.6. Equation 2 is negative 1 over 1 plus j2 v1 plus 1 over negative j5 plus 1 over 1 plus j2 plus 1 over 5 v2 minus 20 over 5 ix, and that equals 0. So once again, we can simplify the expressions in brackets and get negative 0.2 plus j 0.4 v1 plus 0.4 minus j 0.2 v2 minus 4ix equals 0. Then for equation 3, we get 1 over 1 plus j2 v1 minus 1 over 1 plus j2 v2 minus 1ix equals 0. And simplifying that, we get 0.2 minus j 0.4 v1 minus 0.2 minus j 0.4 v2 minus ix equals 0. So we will make a 6 by 8 matrix again, where the first column is 0, negative 0.4, negative 0.2, 0.4, 0.2, negative 0.4. The third column is negative 0.2, 0.4, 0.4, negative 0.2, negative 0.2, 0.4. The fifth column is 0, 0, negative 4, 0, negative 1, 0. And the seventh column is 10.6, 0, 0, 0, 0, 0. And now we do our second column, 0.4, 0.3, negative 0.4, negative 0.2, and 0.4, 0.2. Our fourth column, negative 0.4, negative 0.2, 0.2, 0.4, negative 0.4, negative 0.2. Our sixth column, 0, 0, 0, negative 4, 0, negative 1. And the final column, 0, 10.6, 0, 0, 0, 0. And finally, putting this matrix in our calculator and using reduced row echelon form, we get that V1 is equal to 68.4 minus J 16.8, or 70 with an angle of negative 14 degrees in volts. V2 is equal to 68 minus J 26, or 72.8 with an angle of negative 21 degrees in volts. And Ix is equal to 3.76 plus J 1.68, which equals 4.12 with an angle of 24 degrees in amps. And this concludes complex number math with calculators. Please come back again.